Good afternoon, grade 12 learners. Welcome to today's mathematics lesson. The lesson is broadcast and brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Our lesson for today is paper 2 revision, and we are going to be focusing on analytical geometry. And we are aware that analytical geometry in our paper 2 contributes about 40 plus minus 3 marks, so it can be between 37 and 43 marks. And over the years, this topic seems to be suffering. Our performance in analytical geometry is dropping over the years, and we need to make sure that we get those marks. At the end of the lesson, we should be able to use the distance, the midpoint, and the gradient formula to solve problems involving line segments. And we know that we are dealing with shapes which are made up of line segments. And we should be able to observe the relationship between gradients of parallel lines, perpendicular lines, and we should be able to determine the equation of a line. And we are aware that the equation of a line, we normally use y is equal to mx plus c. We have different ways of obtaining that equation. We also dealt with this equation when we're dealing with functions. Now, we should be able to solve problems applying analytical methods, e.g. we'll be proving shapes. If a shape is a triangle, you have to prove the different types of triangles that we have. We also use analytical methods to determine the angle of inclination of a line. And we should also be able to solve problems that involve a circle. And you are aware that a circle has its own equation, it has a tangent, it has a radius, and it has codes. So we should remember to revise all the parts of a circle and how we can solve problems involving the circle. Now, I'll just go through the topics for paper 2. You are aware that it's statistics, which contributes about 20 marks, analytical geometry 40 marks, trigonometry 50 marks, and Euclidean geometry 40 marks, and the total will be 150 marks. But today we'll be focusing mainly on the 40 marks of analytical geometry. Now, we are aware that for us to pass, we must target our topics accordingly so that we get the marks that we need. For us to get a pass of about 45%, we need to get 15 marks in analytical geometry. So we have to get more than 15 marks. That's a minimum. And then for us to target a bachelor mark, we must get a minimum of 25 marks for analytical geometry in order for us to get a 60% there in mathematics paper 2. Now, I will go to the information sheet on our formula page. You will realize that the quadratic formula, we use it a lot, but people continue to make mistakes on it. We have our distance formula, our midpoint formula, the equation of a line. We have two versions, that one and that one. We also have the formula for calculating gradient, and we also have a formula for knowing that our gradient is equal to the tangent of the angle of inclination. And we have the equation of a circle. I shall deal with this later on. Now, just a quick reminder on the formulas that we have for our analytical geometry. We are aware that if we are given a line segment AB, we are able to use our distance formula. It is x at B minus x at A those are the points. But remember, if it's PQ, it means where I'm having B, where I'm having A, I'm replacing that with P or Q, whichever the point will be. So it doesn't mean that we shall always be having A and B. In some instances, we can use X2 and X1 to show that our points are different in the line segment. Now, the distance formula, please note that if you square both sides, if it's AB squared, it means you will have the other side also having the sum of the y values, the difference between our y values and our x values being squared there. So we should be able to use the formula correctly in order for us to get our marks. Then we also have the midpoint. We know that the midpoint is the average between the 2 points. You sum up the coordinates of point x coordinate of point A plus the x coordinate at point B. You divide them by 2 because we are dealing with 2 points, and then it will give us the x value at the midpoint, which we have named as xm. And also to get the midpoint y value at the midpoint, you are going to add the y value at A plus the y value at B. You divide them by 2, you will get your coordinates in that way. We move on. Our line segment is still AB. Our gradient formula, we know that gradient is a slope, it is an incline. Those are other terms that I use to talk about gradient. So we should be able to get our gradient using the formula. And remember, whether if you start with coordinates of point A, it means it will be y at A minus y at B over x at A minus x at B. It works either way. It does not mean that you always have to take the upper one or the lower one first. The order is very important. If you start with coordinate y coordinate of point A, then we must also start with the x coordinate of point A on the denominator. Common mistakes that we make: people do not refer to the formula page and they write the formulas wrong, and in the process we lose marks in this simple topic. We move on again. We know that we have parallel lines, and the notation for representing our parallel lines, it's making sure that we draw those arrows to indicate that AB is parallel to CD. And the common property is that parallel lines have equal gradients, and we use this a lot in analytical geometry. You will see as we answer questions, and we should always have a picture of what we are dealing with as we move along. Perpendicular lines are lines that intersect at right angles. So the angle of intersection there, it's 90 degrees. And also we use gradients. If AB is perpendicular to CD, then it follows that the gradient of AB multiplied by the gradient of CD, the product must give us -1. This question is asked a lot, and sometimes we fail to answer it correctly, and in the process we lose marks, but we will discuss as we answer the questions. So we have talked about perpendicular lines. The product of the gradients must give us -1, and we are aware of that one. We move on now to the equation of a line. We have seen the formula, and we also have this one that we also use in our paper 1, y is equal to mx plus c. And we know that m is our gradient and c is our y-intercept. Then there is another form, especially when our gradient is a fraction. Sometimes we'll be expected to leave our answer in the form ax plus by plus c equals 0. We should be able now to navigate between the two types of formulas where you are supposed to leave your equation in the form y is equal to mx plus c, or you have to also move from here back to that standard form, especially if you are supposed to use the gradient to answer any other question. Now, we will talk about the angle of inclination. Our angle of inclination, like I said, incline, slope, all this refers to gradient. And our angle of inclination, we use the gradient to find the angle of inclination. And it is the angle between the x-axis, the positive x-axis, and the given line segment. Now, if you check, we are only measuring the angle on the positive side of the x-axis, and you will realize that if our gradient is positive, our angle of inclination is acute. It is above 0 degrees but less than 90 degrees. If we are having a negative gradient and our line is sloping like that, it's a decreasing line because our gradient is negative, our angle of inclination will be above 90 degrees but less than 180 degrees, and we call that one obtuse angle. Then we also have collinear points. Collinear points are defined as points that lie on the same straight line, and the common characteristic for our collinear points is that they are having equal gradients. So if you are to prove that points are collinear, you are supposed to show that the gradient of AB is equal to the gradient of BC, which is also equal to the gradient of AC, whichever is easier for you to do. Once one of these gradients is not equal to any of the other ones, then it means the points are not collinear. Sometimes they will not give you a line, they'll just give points A, B, C with coordinates. Then you are supposed to prove that the points are collinear. We are going to use gradient. Moving along, then we have a circle, the new kid in the block. These other ones, we did them from grade 10 and 11, and the circle came in 2022 as our new part of the curriculum. The equation of a circle, we know that a circle is defined by looking at its center as well as its radius. So we are going to look at the equation of a circle where the center is the radius, is the origin, and the equation is given as x squared plus y squared is equal to r squared. Please take note of the form of the equation so that we do not make mistakes when we answer questions. If the question asks you what is the radius of the circle, then it means, because on our equation we are having r squared, it means if the question asks you what is the radius becomes the square root of x squared plus y squared, like that. So, but on the equation we substitute r squared. How do we find the radius? Remember, you may be given a point A with coordinates x at A, y at A. The origin, we know that it's all, the x is 0, the y is also 0. And using our distance formula, we are able to find the radius that we are able to substitute into the equation. We will see as we answer questions. Then we have another circle where the center is anywhere in the Cartesian plane, and the center now is given by the coordinates A and B. The equation of the circle becomes x minus a squared plus y minus b squared is equal to r squared. But in some instances, you will find out that the equation is given in the form x squared plus y squared plus bx plus cy plus d equals 0, like that. Now, also, we should be able to move in between the two forms of the equation of a circle as we move along, where the center now is no longer at the origin, and we will be using the method of completing the square that we did in grade 11 to help us determine the equation of the circle in the given form. I know we have done this. We will move on now. The other part that we look at a lot in analytical geometry are our triangles and our quadrilaterals. We are expected to revise and know the properties of the basic quadrilaterals. Our trapezium, we know that it has only one pair of opposite sides that are parallel, and we do not talk about the equal sides in a trapezium. Then we have our parallelogram. You will find out that most of our quadrilaterals that we are studying or we have studied are having the properties of a parallelogram, and I will not mention them because you already know them. You just need to go back and revise them. So you look at our sides, the size of our interior angles. We also look at our diagonals. We look at the fact that are our angles bisected or not in these properties. Please revise the properties of the trapezium, parallelogram, our rhombus, rectangle, square, and kite. These are the basic quadrilaterals that we must know their properties. I have listed them there. You will go through them at a later stage as we are able to, and we have been doing them since grade 8. If I remember well, we do quadrilaterals from grade 8 up to grade 12. But somehow we forget these properties along the way. Also, we must be able to know the formulas for calculating the areas of these basic shapes. We have done this on measurement, but I know that we quickly forget, so we must revise the formulas, because in an exam situation, you may be asked to calculate the area of the shape that is given. Also, we should be able to know our transformations. How do we transform our translation? We must know how to use them. We did them at GET. We need to always revise them. How do we translate a shape? And we get these marks for free. Now, we move on. I was giving you a chance to go through the properties of these quadrilaterals. We know that a parallelogram and a rectangle are having the same properties save for the interior angles. Those are the ones that are different, as well as the other difference is that our parallelogram, the diagonals bisect each other. In a rectangle, the diagonals also bisect each other, but the diagonals are equal in length, whereas in a parallelogram, they are not equal in length. So these are the things that we must familiarize ourselves with and make sure that we know these properties by heart. I will move on and just give you the hints of how you are supposed to prove. If you are given a shape like a trapezium, you know that you need to show that only a pair of opposite sides are parallel. To prove a parallelogram, you must prove that diagonals bisect each other. To prove a rhombus, you know that all the properties of a parallelogram apply and the diagonals are perpendicular to each other in a rhombus. In a rectangle, we know that all the properties of a parallelogram apply, and we know that the interior angles in a parallelogram, they are not right angles, but in a rhombus, in a rectangle, sorry, our interior angles are 90 degrees. And to prove that, you can find the gradient of the adjacent sides, and you show that the product of the gradients of the adjacent sides give us a product of -1. Then you will be able to show that that angle is 90 degrees. A square, we know that all the properties of a rhombus apply in a square, and we know that the interior angles of a circle are 90 degrees, and we know that the diagonals bisect each other perpendicularly in a square. A kite, we know that adjacent sides are equal in length. A pair of adjacent sides are equal in length, and we know that one diagonal is bisected at 90 degrees. Now, I have been mentioning some of the things that we need to know before we answer analytical geometry questions. We must remember our transformations, our formula for distance midpoint, our inclination. We should be able to solve equations because we will be dealing with equations of lines, the intersections, and so on. We know that trigonometry is applied in analytical geometry, and we also know that Euclidean geometry is applied in analytical geometry. Our area rule, our formulas for area, we must know them. Our sine rule, our cosine rule can be applied in analytical geometry. We are aware of that. Now, our approach to questions. Please check. If the question says solve using analytical methods, it means you cannot use trigonometry or any other topic to help you solve. You must use the analytical methods. That's our distance, our gradients, our angle of inclination, and so on. We must use those other than using trigonometry and other topics that are infused there. You are aware that our Euclidean geometry knowledge is used in answering the questions. Like the words that we use, for example, bisect. I have talked about bisection. An angle can be bisected or a line can be bisected. If it's a line that is bisected, you know that it's a midpoint. If you are having a product of gradients, they give you -1. It's a way of proving that the lines are perpendicular to each other, or the angle there is 90 degrees. To prove that lines are perpendicular, it is always required that you show that the product of the gradients is -1. We shouldn't start by asserting that the gradient is -1. It has to come at the end. You will see as we answer questions. When we are determining the equation of a line, we know all the aspects of an equation of a line. We need gradient, we need the y-intercept for us to get the equation of a straight line. Therefore, we must know all those things. Now, I will not leave out the equation of a vertical line and the equation of a horizontal line. We are aware that that's a vertical line, that's a horizontal line. And we know that these are drawn on a Cartesian plane. We know that vertical, we are dealing with x values. Horizontal, we are dealing with y values. So if it cuts the x-axis somewhere, this is our Cartesian plane, that's our x-axis, and you are told that here the coordinates are 2 and 0, and here the coordinates are 0 and 3, for example. It means the equation of this line will be given by y is equal to 3. It's a horizontal line. We know that for a horizontal line, our gradient is equal to 0. And for a vertical line, we know that our gradient is not defined. So we don't need to show m. It will be given as x equals. You are able to see that for this one, we said our x-intercept there, it's 2 and 0, meaning the equation will be given as x is equal to 2. And we are able to generalize and say for any vertical line, x is equal to p. We know that if along that equation, it's our x-intercept is p, it means it is x is equal to p. If our y-intercept is 0 and t, it means it will be given as y is equal to t for our horizontal line. Now, step 1, please read and understand the question scenario. There's always a story before the diagram when we are dealing with analytical geometry problems. And remember, add information to your diagram as well if it is not given. We must use our diagram effectively, but remember, diagrams are not drawn to scale, so we should not take a ruler and start measuring. The question says find the length. We can't take a ruler and start measuring. We use analytical methods to help us answer that question. Now, we also look for the keywords in the statement. A and B parallel to D and C, something like that. If it's not indicated on the diagram, show your parallel lines. It makes life easy and it helps you to decode the difficult question. It becomes easier because the picture is different from what you are just seeing on the diagram. When you add information, the picture becomes more simpler and it helps you to see things that are a bit hidden. Step 3, we interpret the question extracting key information from the keywords. We know the keywords: parallel, gradient, perpendicular, bisect, intersect. So those words help us to answer the question. Remember, analytical methods, we are having our formula to help us solve the problem. So we select the correct formula and we should be able to substitute correctly into the formula so that we are able to do the correct arithmetic calculations or use your calculator to do the calculations. Also, we must remember to answer the question and to conclude exactly on what we are asked to do. If a question says in 1 point or in 3.2 says, show that the coordinates of D are 2 and 4, and question 3.1, it's saying, calculate the distance of a given line. You cannot use the coordinates in 3.2 to answer 3.1. You always have to show those first before you can start using them, or you can use them in the question that is after it there. Now, also, as you get answers for the question, please make sure you add that information to your diagram. It will help you a lot in getting more information and helping you answer the coming questions. So from here, we are going to do an activity, and I will give you time to do the activity. Then I will explain some of the things that I have just said and apply them as we answer questions. Now, let us answer activity 1. I will humbly ask you to attempt question 3.1 up to 3.23, and I'm going to give you 7 minutes to answer 3.1 up to 3.23. Remember, you read the question scenario and understand it, and try to add information to your diagram to help you understand the question better as you answer the question. So 7 minutes to attempt 3.1 up to 3.23. Welcome back. Now we are going to look at the information and help us answer the questions. Now it says write down the equation of PR. If you check PCR, what comes into your mind? They lie on the same straight line. Those are collinear points. So it means the equation is going to be the same. If you check, this is a horizontal line. The y-intercept is 0 and 5. The coordinates of r are 3 and 5. So you are able to see that our y value is the one that is constant there. So the equation of PR, we will answer it as y is equal to 5. We just get our 1 mark. There is no need for you to calculate gradient. It's a horizontal line, and we know that the gradient of a horizontal line is 0. So you cannot write it as y is equal to 0x plus 5. We cannot. Anything multiplied by 0, it's 0. Therefore, it is y is equal to 5. I've explained this for the equation of a horizontal line and vertical line. Now, we move on now to 3.2. It says calculate the following. The gradient of RS. So we are having the point R and the point S, and we are going to use our gradient formula. And we know that the gradient RS will be given by y at R minus y at S over x at R minus x at S. It helps you to substitute correctly, and we are aware that we use small letter m for gradient, and we use our points R and S as capital letters. So it will be our y at R is 5 minus our y at S, it's negative 7 over our x at R is 3 minus negative 3. And this will give us 5 minus minus, it gives us positive 12 over 6. And our gradient for RS will be equal to 2. We are done. So it's 2 marks, substitution into the correct formula and answer. Now remember, we can also use the gradient of RS as y at S minus y at R over x at S minus x at R. It will give us the same answer. We move on. So we are also supposed to calculate the size of angle theta. Are we able to see angle theta there? So we calculated the gradient of RS and we found it as 2. The size of angle theta, we are able to see that angle theta is the angle of inclination for the line TP. So to calculate that, we need the gradient of TP, but we know that we are given that PT is parallel to SR. So we are able to see that the gradient of our TP is equal to the gradient of our RS, which is equal to 2, and we know why. We are given that PT is parallel to RS. So we now have the gradient of PT as 2. And how do we get the angle of inclination? We know that our angle of inclination is given by tan theta is equal to the gradient, which is 2. And this will give our theta. If you check, theta is positive. So we use our calculator, shift turn 2, and we will get our theta as 63.43 degrees. We get our 3 marks. So the first mark goes for us knowing that the gradient of TP will be the same as the gradient of RS because those are parallel lines, and then using the information tan theta is equal to gradient, and for the answer we get our 3 marks there. We move to the next one. We are saying 3.23, we are supposed to find the coordinates of point D, and point D becomes the y-intercept of SR. How do we get the y-intercept? The first thing that we can do is know that the gradient of SD, you are able to see that I'm also using collinear points again. The gradient of SD is equal to the gradient of SR, which is also equal to the gradient of RS there. So you use any of those. So I can give the coordinates here as 0 and y, and then use any of the given points, equate them to 2. I'll only have y as my variable, and I'll get my y as -1. And so you'll get a mark for the method, the y value, and for the coordinates. We are done. Those are the coordinates of point D. May I give you 3 minutes to answer 3.3? The information is here. Let's quickly answer 3.3. Welcome back. I hope we were able to quickly answer this one. Now, if it is given that TS is 2 root 5, you can see that TS, it's a distance. This is 2 root 5 units. So how do we find distance? So in a way, you are already able to see that here you are supposed to use your distance formula. Ne? So let's look at TS is equal to 2 root 5. So we can do our substitution. We know that for our distance formula, it is square root, or we use squared, it's up to us. So it will be square root x at t minus x at s squared plus y at t minus y at s squared is equal to 2 root 5. Then I'll do the substitution. It will give us x at t, it's negative 5 minus negative 3, and we are squaring this, plus y at t, we don't know it, it's k minus negative 7. We square this under the square root is equal to 2 square root 5. To take away the square root, we know that we are squaring both sides. Remember, I said we need knowledge of how to solve equations. This, without using a calculator, there is no more square root because I've squared both sides. Negative 5 minus minus, this becomes negative 2 squared plus k minus negative 7, this becomes k plus 7 squared. 2 root 5 squared, I know that will give me 20. Negative 2 squared will give me 4, plus this will give me k squared plus 14k plus 49 is equal to 20. If I bring 20 this side and I bring 4 as well, this will give me k squared plus 14k. 49 plus 4 will give us 53 minus 20, that will give us 33 equals 0. I can factorize this one. So it's plus 33. Then I know my factors will be k plus 3, k plus 11 equals 0. And therefore, I'll get my k as negative 3 or my k as negative 11. Now, remember the rejection. The diagram is just helping us to visualize. You are able to see that the point T should be above point S. Therefore, our value of k cannot be negative 11. So we can simply say that one is not applicable. Therefore, our k will be given as negative 3. Now, I'll show you an alternative method that you can use, but you can see that we are also revising our solving of our quadratic equations. Hence, we will get our k as negative 3 in both methods. So we'll get a mark for the substitution into the distance formula. Simplifying to get our standard form, we get our factors, and then choosing the correct solution will get our 4 marks. Or if you choose to use the alternative method, again, substitution, the method of getting our solution, simplification, then we get our both values of k and the selection of k as -3 there, we get our 4 marks. The next one, 3.4, we are told that parallelogram TDNS with n in the fourth quadrant is drawn. Calculate the coordinates of n. Now, this question requires us to add more information to the diagram to help us solve. So I will give you 6 minutes to answer 3.4. No, let me give you 5 minutes because we have done part of the work already. Let's answer 3.4 and 3.5 in 5 minutes. Let's attempt quickly. Welcome back. I hope we were able to get the coordinates of n. Now, we use our diagram effectively. We are told that TDNS with n in the fourth quadrant is drawn. Calculate the coordinates of n. So, you must come up with a parallelogram. And we know that a parallelogram takes the shape like that. So it means our n, it's somewhere like this. We don't know the coordinates of n. We know that this one is parallel to that one. And we know that this is parallel to this for us to get a parallelogram. It helps you see what can help you get the solution correctly. We say the coordinates here are 0 and -1. So looking at this, we go and recall the properties of a parallelogram. So what can help us get the coordinates of n? I have coordinates of s and d, meaning I'm able to get the midpoint here. And I know that the midpoint of SD is also the midpoint of TN. So for K, I know that the coordinates of T are -5 and -3 to make my life easy. Once I have the coordinates of M, the midpoint here, it means I have another diagonal here, which is diagonal TN, which I don't have the coordinates of xn and yn, but I can be able to get the coordinates of M, the midpoint of SD, which is also the midpoint of TN, and this will make my life easy. I'm able to get my solution using the x, the midpoint for the x values. I'll add -3 and 0, divide by 2. It gives me -3/2. I equate this to xn plus -5/2, and I'll get my x at n as +2. And to get the y value again, I'm able to get the y value at this midpoint at -1 plus -7/2, and that should give me -4. I then equate this to my y value at n plus my y value at t, which is -3 divided by 2. I equate it to the y value at the midpoint, and that will help me get my solution. Now, we can also use translations here to get to our solution, but it needs us to understand those translations, because remember, we did the rules of translations in grade 8 and 9, and we must go back and revise them to help us get the solution easily. So you'll get the coordinates as, so you'll get a mark for the method of getting our x and y values, and then for the answer, that even if for this one the examiner was lenient, even if you have not shown the working, you are getting full marks, because like I'm indicating, you can use your translations or any other method. Now, question 3.5. Again, you can see that it's transformation geometry that we did in grade 8 and 9. And we must be able to revise this, because if you can't get those 3 marks, it means you are losing these ones. Already that's 2% in an exam, and we cannot afford to lose marks like that. We must get these marks. Now, remember, a reflection, it's a mirror image of that particular point. And we are aware that if I reflect P about the x the y-axis, I know that the distance from here to that point there, if here the coordinates, you are able to see that the coordinate that is changing there is the x value. The y value is 5 throughout. So the coordinates of P, we know that our y value will be 5. So we just look for the x value that we're not able to calculate here. It will be x and 5. The coordinate, it will be negative x and 5. The coordinates at the other point, the x value changes to a positive. It will be positive x and 5. Here it is negative x and 5. And then the coordinates of r, you are able to see that r here, the coordinates are 3 and 5. When you reflect, it means the coordinates of the reflected r here will be negative 3 and 5. So the x value changes. So this point and that point, it's a reflection. You are able to see that the coordinates of D are 0 and negative 1. We need to find the size of angle R, D, R reflected. So we need the size of this angle here. Now, again, for this question, we can use different methods. You are able to find the distance dr, you are able to find the dr prime, which is the reflected part, and you are also able to find the r reflected distance using your distance formula, or by simply saying this is 3 minus negative 3, this will give us 6 as the distance of r and r reflected. dr, you can use your distance formula, and dr reflected also you can use your reflected point, and then from there you are able to use the cosine rule to find the angle there. But I have decided to use analytical methods. I know that the angle here, it's going to be 63.43 degrees, because the angle of inclination here and that line, they are having the same gradient, so the angle of inclination will be the same. Now, I know that the angle inside here, I'm using the bigger diagram because this one is a bit small. You are able to see that this will be 63.43. And I'm aware that if I have a line like that, I will also have the angle of inclination of this one. And I am able now to get what I need to get. I'm able to get the angle of this piece here. I know that this becomes a right-angled triangle, this. So I'm able to get that piece. Once I get that piece, because of the reflection, I'm able to get the other piece on the other side as well. Even if I don't use the angle of inclination, I can still get that angle there. So if I use the sum of angles in a triangle, if this is 63.43, this one will be 90 degrees because it's a right angle. If I look at triangle OFD, I'm able to get this smaller angle here. And once I get this smaller angle here, it will be the same angle as that one because these two triangles are congruent. So if I add these two, I will get the size of angle RD and my R reflected that side. So let me give you the solution that I thought was easier to follow. You are able to see that ODF, which is the small piece here, we are getting it as 26.565 or 26.57 to 2 decimal places. And then you are able to see that these are congruent triangles. So it means this smaller piece also will be 26.565, and that will give us our angle as 53.13 degrees. Like I said, you can use your distance formula, find distances from there. You can use, like I've indicated, you can use your trigonometric ratios. You can also use your sine rule and cosine rule as they can apply for this particular question. So we are going to get marks for getting the angle of inclination as that one, and then knowing that ODF is that one, getting ODF, and then multiplying by 2 to get the third mark. We will move on to activity 2, where we are given a circle. We are given a circle. I will give you 8 minutes to answer question 4.1. No, let me give you 10. We are able to answer these questions in 10 minutes. Let's answer the whole of 4.1 up to 4.15. Welcome back. It's an interesting question. I hope you managed to answer as much as you can. If you did not finish, I understand. In the interest of time, let's quickly mark. Now, we need the gradient of SR. And if you look at the question and the information, you are able to see that SR is a tangent, and you are able to see that PK is a diameter. So, to make our life easy, we are aware that the tangent is perpendicular to the diameter or radius. So, on the diagram, we are having information about the gradient of a diameter. And once we get that gradient, we are able to get the gradient of SR, which is our tangent. And we have one point P, which lies on SR, meaning we are able to get the equation once we get the gradient. So to answer this one, we will start by calculating the gradient of PK. Our y at P, it's 5, minus our y at K, which is -3, over our x at P, it's -4. Our x at K is 0, and that will give us 8 over -4, and we'll get our gradient at -2. So from there on, we are able to find the gradient of SR. We know that the gradient of SR multiplied by the gradient of PK, we should get -1 because the tangent is perpendicular to the radius as our reason. So using that, I can now substitute here. I'll have the gradient of SR times -2 is equal to -1. Then I'll get the gradient of SR as equal to 1 over 2. And I will conclude that it's because the tangent is perpendicular to the radius. Okay. So method, I get the gradient of that one. I get the gradient of SR, my reason for getting that one. So I'll get my 4 marks, or I have shown that step up there. You can still get the 4 marks, but remember it's maximum marks, whilst we are economic in terms of time as well. The longer the method, it means you'll take more time, so we need to be economic. 4.12, we want the equation of SR. We now have the gradient of SR. So it's only 2 marks, meaning I will choose to use y is equal to half x plus c. I have point P with coordinates -4 and 5. This is what I'm going to use. When my y is 5, my x is -4 plus c, and I'll get my c as +7. Therefore, my equation will be y is equal to half x plus 7. So, substitution, answer, I get my 2 marks. So far, we have 6. We move on to the next question. The equation of the circle in the form. Now, you are able to see that we were not given the equation of a circle. We must determine it from the diagram. If you check, M, the center of the circle, is the midpoint of, so if it is the center, you can conclude that PM should be equal to MK, because M is the center, and we know that the center, PK is the diameter, PM is the radius, MK is also another radius. diameter is 2 times the radius. So I'm going to use the midpoint formula to get my center, and it will be given by -4 plus 0 over 2, and I will have 5 plus -3 over 2, and that will give me my m as -2, and 5 minus 3 will give us 2. 2 divided by 2, that will give us +1, like that. And then from there on, I have the values of a and b. I'm short of the radius, so I can substitute. So x minus -2, it becomes x plus 2 squared plus y. My b is 1. I'm substituting. I square that one, is equal to r squared. So to make my life easy, to get r squared, I can substitute any of the points p or k to make my life easy. I'm choosing to substitute the coordinates of point k because there is a 0 there. I'll have 0 plus 2. I square that, plus my y at k, it's -3 minus 1 squared, and that gives me r squared. And this will give me my r squared as 0 plus 2 is 2. It will give me 4 plus -4 squared, it's 16. My r squared will be 20. So my r squared equals 20. Therefore, x plus 2 squared plus y minus 1 squared is equal to 20. So I will get my final mark there. So for getting the center, substitution, then getting my r as 20, then the left hand side and the right hand side, I will get my fourth mark there. We need to find the size of PKR. To find the size of angle PKR, PKR is this angle here. Again, if you check, I'm able to get the gradient of PK. I've already calculated it. And once I use the gradient of PK, I'm able to find the size of angle theta. And this becomes an exterior angle of this triangle there. If you are able to see it, sorry. This angle here is 90 degrees. This angle plus 90 degrees, they should give us theta there as our angle. So using our angle of inclination, we are able to say that our tan theta, we found the gradient of PK as -2. So meaning our theta will be given by 180 minus tan inverse of 2. And this gave our theta as 116.57 degrees. And then from there on, to get PKR, we are going to say 116.57 degrees minus 90 degrees, and this will give us 26.57 degrees as the size of angle PKR, and we will get our 3 marks for that. Now, some questions are not straightforward. They need you to get something and to know something before you can easily answer, but we are using analytical means. We move on to the last one. It says the equation of the tangent to the circle at point K in the form y is equal to mx plus c, and that question is 2 marks. Now, we know that a tangent is a line that touches the circle at only one point. And if you look at this, we know that the tangent is perpendicular to the radius, it follows that SR is parallel to the other tangent that passes through point K, because this is perpendicular, that one is perpendicular. It means they are equal distance apart, therefore they are parallel to each other. It follows that the gradient of the tangent should be equal to the gradient of SR. Why? Because we are saying these are parallel lines have equal gradients. So the tangent is parallel to SR. You are deducing this from the diagram. Now, if you do not draw this tangent at point K, it becomes difficult for you to get that the gradients will be the same, because these will be parallel lines. They are equal distance apart. So from there on, I'm able to say the gradient of SR is half. So it means this one will be y is equal to half x plus c. But I know that point K, it's my y-intercept, meaning my c will also be equal to -3. So this will be equal to half x minus 3. That is the equation of that tangent there. I get my marks. Now, due to time, we are not able to do activity 3, but it's a continuation of activity 2. We are going to look at these in our next lesson when we revise for the final, the other form of the equation of a circle, as well as intersecting lines to circles and our circles intersecting. We know whether they are intersecting twice, once, or they are intersecting externally. We'll discuss that. And then I will move very fast because time is not on our side. Now, this was supposed to be homework. It involves 2 circles. You can quickly take a picture, or you can go and look at this question paper. The solutions are there. The solutions are there. Now, please note that in conclusion, for our analytical geometry, this is an easy topic. Anything with a diagram, the answer is in front of you. All we need to do is to analyze the given information, and we identify what we can use to help us get the solution. Remember, diagrams are not drawn to scale. Please do not measure anything. We must make sure that we use our analytical methods. We use the diagram effectively. Add information to your diagram. Label things so that you are able to see what can help you get to the solution that we need to get. We write information in our diagram and we continue to add for subsequent answers. We add additional line. You saw when we're doing the reflections, I was able to draw a diagram so that you get a picture of what is happening and you are able to see which angle you are calculating. And please remember, if in the question you have calculated theta, do not use theta to calculate the other angle that you are supposed to get, because it creates some confusion, because it becomes difficult for us to know which theta you are referring to. I indicated this one that we cannot use information given for 3.2 to answer 3.1, as this is not allowed. We must revise the properties of our triangles and quadrilaterals, and we also revise our transformation rules as they help us in answering analytical geometry questions. You can use color. It helps to make you see which sides are equal, which sides are parallel. And please refrain from making assumptions. If they've said if they've not said is a midpoint, we cannot just make an assumption that it is a midpoint because it looks like it is equal distance from both sides. It has to be indicated. For example, we know that if it's a midpoint, it's either they will give us and show us that AC is equal on a diagram. But if this information is not indicated, we cannot just assume that point C is a midpoint if there are no lines to indicate, or if the statement is not stating that C is a midpoint. Let's continue to practice and make sure that we get some enough rest. We use all the resources that are available to prepare for our final examinations. I thank you. Have a good afternoon.